Welcome. This is the beginning of our unit on acoustics, and this is going to be one of the more technically challenging parts of this class. But the idea here is not that you come out of this being a physicist and understanding every possible detail of how sound propagation works. The idea is really that you just have some overarching principles that will help you understand why sounds work the ways that they do and what that means for language, right? So you're not going to need to know everything about waveform physics or anything like that, but I want to give you an overview of uh, when we do things with our vocal tract to make sounds like vowels and consonants. What are we doing with those movements? I'm sorry, I keep checking the levels here. I think it's okay. All right, good. So yeah, that's what this unit is for. There's a lot of pretty complex technical material here. Don't worry if there are parts of it you don't understand. Just ask questions, and you don't need to have all the details down. I just want you to have the big picture of what's going on. Okay, so we're going to start by reviewing some things about the vocal tract, the larynx, and voicing and waves that we talked about briefly in a previous week of this class. And so let's start here with, again, a human head and a vocal tract. This is an MRI image that's taken mid-sagittally, so right through the center of somebody's head, as if you were going to split them in half through their nose, basically. And the only thing to recognize here, I mean, you should be familiar with what the vocal tract is like now, but the point here is just that the lungs are going to be down here, and all of the air pressure that we use to talk or sing or speak or breathe or whatever all comes from the lungs, and so it's going to come up your trachea here, your windpipe, until it hits the first linguistically significant airstream constriction, and this is the larynx or the glottis. So recall that the larynx is a series of three pairs of cartilages that are stacked on top of each other in sort of complicated ways. The details are not hugely important, but basically by moving these cartilages around, you're able to manipulate these folds of tissue that we refer to as vocal folds in order to either bring them together, as in this picture, and so now this membrane is covering the entire cavity that connects your trachea and your pharynx. Right? That cavity is called the glottis. You can close your glottis, as in this picture, or open your glottis, as in this picture. Right? So this is the first linguistically significant airstream obstruction that you're going to hit when air is coming up from the lungs or when pressure is coming up from the lungs, and it's the glottis, and you can open or close it. Here are three important things you do with your glottis when you're speaking. And there are other things, but these are the three we're going to focus on this semester. They're going to be sort of basic settings here. You can have voiced sounds. What does that mean? In a voiced sound, your vocal folds are pulled together so that they're vibrating. They're not pulled together so tight that air can't ever get through. That would be a glottal stop, or it's sometimes called glottalization. Right? They're just pulled together just tightly enough so that air can flow through them and they vibrate. I'll talk about that in a second. You can have sounds that are voiceless. That just means that your vocal folds are held apart and there's no vibration. So maybe like this picture, maybe even wider. And then a third one that's going to be relevant here is aspiration. And this is the kind of sound that you hear for frication or for whispered speech. When I'm whispering, this is all aspiration noise. So what does that mean? Well, your vocal folds are held together closely enough to create turbulent, noisy airflow like a fricative, but not close enough to vibrate. And so an example of that, of a pure glottal frication, roughly, would be the glottal fricative that's in English and other languages, ha, ha. Right? That is the sound of aspiration. And so these are three things you can do with your glottis. There are other things you do with your pharynx or with your larynx and your glottis in speech, but we're going to focus on these three this semester. And here is a review of how voicing works. It's a cycle. So what happens? You put your vocal folds together, and as you close this passage, with pressure still coming up from your lungs, pressure is going to build up below your glottis here in your subglottal cavity. Eventually that pressure, because you're not clenching your vocal folds very tightly, you just have them loosely pressed together, that air pressure is eventually going to push them apart. At that point, the pressure here will dissipate, right, because you'll get pressure rushing through into your supralaryngeal cavity, or your the area above your larynx. The pressure will reduce, and eventually your vocal folds will pop back together again. Right? And then pressure will begin building up because this is closed now, and so on and so forth. And this just repeats. Right? So this is a cycle. It's the voicing cycle. You are not controlling the individual cycles of your glottis. You're not putting them together, putting your vocal folds together, then pulling them apart again, then putting them together again. You are putting them in one sort of configuration where they're loosely touching, and then you're letting the airflow do the rest. And that's what makes them vibrate. So you can't control parts of your body at speeds that are much greater than, maybe 100 times a second, and that would be for very sensitive parts of your motor system. You can't really control things any faster than that, but because the individual glottal cycles are not under control here, your glottis can vibrate extremely fast in normal speech. So as I'm talking, I have a moderately low-pitched voice, and probably my vocal folds are vibrating anywhere between 80 and 200 times a second as I'm speaking. If I had a higher pitched voice, they could be vibrating anywhere up to even 400 times a second while I'm talking. So you're not controlling those individual vibrations. You're just putting your vocal folds in a position to vibrate. Right? If you mapped the position of the folds over time, you'd get a wave. And waves in physics have an amplitude, that's how far they get displaced, and a wavelength, that's the distance it takes for one cycle of the wave to repeat. Right? That's what a wave is, it's a repeating pattern. So if this were actual physical distance, we call this a wavelength. If we're measuring it in time, the wavelength is specifically referred to as a period, and it's the amount of time it takes for one cycle of the wave to pass. Right? Now, usually instead of the amount of time it takes for a cycle to pass, we're going to be more interested in a related measurement, which is how many cycles you get in any given period of time. And that's referred to as the frequency. How many times per unit of time do we get this wave repeating? And in phonetics, we generally use the unit of a hertz. 1 hertz is 1 cycle per second. If my glottis was vibrating 1 time per second, I would be speaking at 1 hertz. You would not be able to hear that, it's too slow. Instead, as I mentioned, the frequency of the vocal folds vibrating in normal human speech is sort of anywhere from maybe at the extremely low end 50 or 60 hertz through a normal range, which I would say is about 100 to 250, up to extremely high-pitched sounds, which might be 400 hertz or even higher. That's generally going to be the frequency of your vocal folds vibrating when you speak. And you can think of this wave as tracking a number of different things. The original idea I gave was to think about the vocal folds being completely closed and transitioning to completely open, and then slowly transitioning back to completely closed. So you could think of this as the position of the vocal folds. In general, we're usually going to be thinking about this as tracking air pressure. And in particular, for the source wave, for glottal waves, you can think about it as tracking the air pressure right above the glottis, or maybe right below the glottis. Doesn't really matter. So below the glottis, we saw air pressure builds up until the vocal folds push apart, and then the air pressure drops until they snap back together again, and then the air pressure rises until they blow apart again, and then it falls, and so on and so forth. So there's lots of correct ways to think about this wave. It corresponds to this voicing cycle. And I will now split off for a second video.